Guys, we're continuing on lesson 5.2, graphing standard and intercept form of quadratic functions. So now let's go into graphing in intercept form. So the intercept form of a quadratic function is y equals a multiplied by x minus p multiplied by x minus q. So this is the form where two linear polynomials are being multiplied. Letter A is a coefficient, while letters p and q are constants. Then it says the blank of the quadratic function are the values of p and q, where p is 0 and q is 0. Well, if I'm looking at that, this is actually going to be our x-intercepts. So the x-intercepts, that's what's great about intercept form. These p and q's are going to be our x-intercepts. So we've got to be careful though, because the signs are changed in the formula, so they're switched. Or they're the opposite sign in the formula. Whichever way you want to write that, you can say the signs are switched, the signs are opposite in the formula. Both ways work. So let's look at example 3. It says to graph function of x equals 2 multiplied by x minus 1 multiplied by x plus 3. Now, at this point, we're not solving these out algebraically. We're just going to use our table function in our calculators to come up with our table. So in your calculator, you're going to enter in 2 multiplied by x minus 1 multiplied by x plus 3. And make sure you're finding that turning point. That's our biggest thing that we want to look at here. We want to look at our turning point, and if we can get some x-intercepts in there too, that always works out well too. So let's start where x equals negative 3. Where x equals negative 3, y is 0. Where x equals negative 2, y is negative 6. Where x equals negative 1, y is negative 8. Where x equals 0, y is negative 6. And where x equals 1, y is 0. So let's look at that function. It says f of x equals 2 multiplied by x minus 1 and x plus 3. And then let's look at our two x-intercepts. So I have this negative 3, 0 is one of them, and 1, 0 is the other. Notice that the opposite of p, which in this case is negative 1, is positive 1. So we do have an x-intercept at 1, 0. So that's good. And then the opposite of q, so q right now is 3, so the opposite would be negative 3, and that's where our other x-intercept is, so negative 3, 0. So let's plot these points on our graph. So at negative 3, where x is negative 3, y is 0. Where x is negative 2, y is negative 6. Where x is negative 1, y is negative 8. Where x is 0, y is negative 6. And where x is 1, y is 0. So we have our parabola. And we have our two x-intercepts at negative 3, 0 and at 1, 0. Now let's look for our vertex. In this case, since this graph is facing upwards, our vertex is going to be our minimum point. If I look at the table, I can find my vertex from there as well. My vertex in this case is going to be at the point negative 1, negative 8. My axis of symmetry is going to be the the line at x from that vertex. So in this case, our vertex is negative 1, negative 8. So it's going to be that vertical line that passes through the vertex. That's going to be where x equals negative 1. And if we look at the end behaviors, as x approaches negative infinity, y is approaching positive infinity. And where x is approaching positive infinity, y is still approaching positive infinity. So therefore, it opens up. And last but not least, our y-intercept, that's where x equals 0, is at negative 6. Let's do the same thing with example 4. Before we get into it, let's see if we can figure out where our x-intercepts are before we go to our table function. So I've got a p-value here, a q-value here, but we want the opposites. So I'm going to guess that my x-intercepts or at 4, 0, because it's the opposite of p, and then at negative 2, 0. But let's see this when I plug it into the table function. So I've got negative x minus 4 multiplied by x plus 2. All right, so let's start off at negative 2. So where x is negative 2, my y value is 0. Where x is negative 1, my y value is 5. Where x is 0, my y value is at 8. Where x is 1, my y value is 9. Where x is 2, my y value is 8. And let's add a few more. Where x is 3, my y value is 5. And where x is 4, my y value is at 0. So let's plot these points. So I'm at negative 2, 0. Negative 1, positive 5. 0, 8. 1, 9. 2, 8. 3, 5. And then 4, 0. So there's my parabola and my graph for that quadratic function. Let's look for my vertex. So first off, in this case, if I look at this parabola, it is a downward facing parabola, so the direction opens down. So in behavior here, as x approaches negative infinity, my y value is approaching negative infinity. As x approaches positive infinity, my y value is still approaching negative infinity. So now we can look at our vertex. In this case, should be our maximum point, which is up here at 1, 9. And our axis of symmetry is going to pass through that vertex, so it's going to be the vertical line passing through that vertex, which is going to be x equals 1. And we've already talked about our end behavior. In both cases, as x approaches negative infinity, our function is approaching negative infinity. And as x approaches positive infinity, our function still approaches negative infinity. And remember, your end behavior for a parabola should be the same in both directions. All right, guys, that's all we have for 5.2. Stay tuned for the practice.